Okay. Well, it's looking like we're right on the top of the hour, and I think I'd like to say welcome to everyone who's joining from all around the world to this now, is this the 9th special STEAM seminar, I believe?
Yes, it is. This is the 9th event of the seminar series.
That's wonderful. I am really amazed that this continues to draw people in, and it's such an the speakers are continuing to be very engaging and exciting to hear. Tonight we have 2 speakers that will be leading us in a conversation around 2 radically different.
Sorry.
Is that correct? And I'm Christopher Brownell. I am a professor of mathematics and STEAM education at Fresno Pacific University in Fresno, California, where right now it's 7:00 p.m., which is sort of an unusual time. This is actually a right in my wheelhouse, kind of perfect time. And quite often we do these and it's midnight, and that's kind of nice that we're not, for me anyway. And but I sure hope we're all safe and dry. I understand there in Korea, there's a bit of a typhoon blowing your way. And Christoph has joined us. He's looking better than he might have been. How are you, sir?
I'm fine, thank you. I'm really happy to be here.
Excellent. I'd like to say thank you to Mr. Park and all those at 4D Frame for putting these seminars on. But with that in mind, I'd like to get right to it. Tonight's first speaker will be John Lok Yoon. I'm going to try and say it as best I can, and he is former CEO of the largest telecom company in South Korea. Is also presently at least partially a professor at a university there. I'm not sure I heard, but he's going to talk with us tonight about discoveries he's made in the data ocean out there and how quickly things are changing. Sir, please, you have the floor. You have our windows.
Okay, thank you, Mr. Christopher. It's my great pleasure and honor to be here to share my ideas, not only here in Korea, but also throughout the world. You are there in the evening, right?
Yes, it's evening here. It's very early morning in Finland.
Okay, Finland.
Christoph is.
Okay. Actually, I met Mr. Park Hoger at the summer vacation all of a sudden. And he suggested me to make a presentation in this seminar today. So I agreed. I didn't know what this conference is, but only the STEAM. Only the topic that I've heard from Mr. Park is STEAM. So STEAM is very crucial, not only for the Korean economy or Korean education, but also in this dynamic, the second big discovery era, STEAM is very crucial to the young generation. So that's why I agreed to and accepted this presentation today. Let me introduce myself briefly first. Please. My name is Jonglok Yoon. I'm a professor of Hanyang University. There, I'm supporting some AI graduate school to improving their imagination further in depth. And prior to that, I was a Vice Minister of Science and Technology and the future planning of the previous government of Korea. it was 2 years. And prior to that, I contributed 28 years in Korea Telecom. It's a legacy telecom operator in Korea. At that time, when I joined the Korea Telecom, almost 35 years ago, one telephone line, the fixed line telephone line here in Korea, is worth about one apartment. It's very expensive.
Wow.
Yeah. But nowadays, almost 40 years later, Korea is one of the best infrastructure throughout the world. So I'm very proud of my experience here in Korea. Let me introduce my episode 52 years ago episode. At that time, I was a primary school student. So 1969, 1969, July 16th, the Apollo 11 was launched. But at that time, I have no TV. We don't have TV set at home. So the only one friend in my class has one TV. So all of my students, my friends gathered there in his home, and we watched Apollo 11 launching, situations.
Mm-hmm.
At that time, the
Recording in progress.
At that time, the capsule, Apollo 11's capsule has one small computer. And then they communicate each other with the NASA headquarters computers, right?
Yes.
So the 8 days of journey from launching to the moon and to come back to the Earth again, the two computers communicate each other to control the journey of the 8 days. So nowadays, I found how big was the computer in the capsule in Apollo 11. The memory capacity of Apollo 11 was 78 kilobyte, 78 kbytes.
Wow.
Only 78 kbytes. But this smartphone I have is a Samsung Galaxy Note Ultra 20. The capacity of memory in this smartphone has 256 gigabytes. Right? If we compare those two capacity as far as memory is concerned, 4 million times within 42 years. So everybody in Korea, they have this one. 4 million times bigger than Apollo 11's capsules computer science. So that's why I think we are living on the great big data ocean instead of regular sea world. So the topic today I'm going to raise is like this. I like to share my topic here. Let me see. Can you see my slide here?
Yes.
Okay, the topic is make one from zero, which means make something from nothing. Based on my term, the second big discovery year on the big data ocean. As I mentioned earlier, our computing capacity is expanding dramatically. So every day we make a lot of data. So if we summarize all of data throughout the world, it's a huge amount. So the ocean, the new data ocean, big data ocean, is very different compared to the regular ocean. The 6 big oceans on the Earth is fixed, but the data ocean is getting bigger and bigger day by day. So that's why we have to utilize and cultivate new technologies, science, and economics on top of this big data ocean. So the topic that I'm raising is make one from zero. The hegemony of 500 years before and now is very different. 500 years ago, the hegemony requires big, strong, and safe ships for the sailing and conquering the ocean. First time they utilized the wind, but wind is not enough. They invented steam and the electric. Nowadays, the aircraft carrier, they use atomic power, right? So like this strong and safe ships was a hegemony of 500 years ago. That's, I'd like to call it the hard power. So left-hand side, the hard power is absolutely required. But 500 years later, we don't need like that ship, but we need very smart ship. It's invisible and intangible, but we actually need smart ship for the great big data ocean. So I'd like to call it AI. AI is a smart ship on the data, big data ocean. So that's why AI is very crucial in this dynamic data era. So AI don't move through the wind or steam or electric power. AI moves invisible and intangible, but very strong soft power. That's my point here. So I'd like to call soft power is a real hegemony in 21st century. Before I go further into my presentation, I'd like a small quiz to you. What is the antonym of the memory? Actually, what, Christopher, what is that?
Is it forgetting?
Forgetting. Yeah. Yes, forgetting.
Yes. Okay, I'm glad I got one right.
Right. 10 years ago, Honorable, the President of Israel, Shimon Peres, asked me this question. Mr. Yoon, what's the antonym of memory? So I said, it's forgetting. But he said, yeah, forgetting is another answer. But I think the antonym of memory is imagination. So I asked him, why imagination instead of forgetting?
Interesting.
And then President Shimon Peres answered like this. Memory is a journey to the past that we already have experienced. But imagination is another journey to the future that we have never experienced. So that's why he said the antonym of memory is not forgetting, it's imagination. So I'm shocked, right? I'm very shocked. So nowadays, imagination is very, very important compared to any others. As you know well, Uber, everybody knows Uber, right? Uber is 13 years old, very young student, right? But within 13 years, the market capitalization of Uber is something like GM. They produce 30 million cars throughout the world. Plus Toyota, they make 10 million cars throughout the world. And Hyundai in Korea, they make 5 million cars every year. But the Uber, they don't make car at all. They don't have car. They don't have cars. They don't make car. But their market capitalization within 13 years is somewhat like GM plus Toyota plus Hyundai. They don't make cars with materials. they made innovation from small imagination. The founder of the Uber, their imagination is like this. Everybody in this audience have your own cars, right? But 96% of your cars is parked in the parking lot. We drive only 4% of the car, but we own the car, right? So the founder of the Uber, their imagination is next generations, our young generations, our next generation, probably they don't want car. They don't want to own the car. Instead of sharing or subscription is much viable compared to having owned their own car. You know Airbnb? Airbnb is 12 years old. It's a very young student, right? The founder of the three young people at the time, they said, why we have to have own our rooms for hotel, like a Hilton or Marriott. Hilton Hotel, they have 10,000 rooms throughout the world. Marriott, 80,000 rooms throughout the world. Right? So instead of having their own room, we can share our house throughout the world. That basic concept was the initiate of the, that imagination, small and primitive imagination was the source of the, the Airbnb. Like that, 19 big companies throughout the world, they make great innovation from very small imagination. Just one company like Johnson & Johnson, they make products from materials. But the other 19, the largest market capitalization company throughout the world, they don't make products from natural resources. They make great innovations from very primitive imagination. So that's why STEAM education is very much important. As I mentioned earlier, the Apollo project last week, this was broadcasted Discovery Channel. So I snapped it a little pictures. So can you see the president here in the United States, Kennedy? And in 1996, July 16th, he launched it. This is the picture of Saturn, Apollo 11. And this is the trace from here to the Earth, from the Earth to the Moon, and come back to the South Pacific Ocean. And actually, July 20th, 4 days later, they launched there in, they landed there in the Moon, and they come back, and again, they launched from moon to Earth, and they come back to the South Pacific Ocean. So you can remember this picture. But my point is, what is the main success factor of this Apollo project? We can imagine many science and technology, like gravitation. How can we overcome the gravitations of the Earth and then merge into the Moon, and again, Moon to the Earth? And also, we can imagine the atmosphere friction. The friction is heavy, so the temperature of the surface of the shuttle is more than 3,000 degrees. So we can develop the materials that can endure those high temperature. And also, instead of solid fuel, we have to develop liquid fuel. And transistors is not enough to make a computer into the capsule. So they have to integrate, invented integrated circuit prior to 2 years prior to the launching. Life science, geology, optics, a lot of imaginations are expected for the successful success of the Apollo project. So my point is science and technology is very important, but the more important was imaginations. So as I heard from the Discovery Channel, the Apollo project, they selected 1,500 different stepstones for the success of the Apollo project. So that's why I described imagination and S. So I'd like to add more than 1,500 S's at the end of imagination, right? You can see the book here in 021. Peter Thiel, very famous Peter Thiel, wrote this book. It's only 200 pages, very small characters, and only one graph here, horizontal X and the vertical Y. He said horizontal X means horizontal expansion, make n from 1. The horizontal X, they requires 1, right? If somebody make 1, we can make it 2 or 3 or 4. We can expand based on his invention 1. Korea, last 50 years, we were very good at this horizontal X economy. We don't have natural economy. We don't have natural petroleum or iron mine or coal mine. We don't. We import those materials from other countries. It takes 1 or 2 months by ship, but we did it. So we make, last 50 years, we make the 10th largest economic volume throughout the world. But Peter Thiel said the horizontal X is almost closing. Instead of that, vertical Y is rising now. Vertical Y is not make n from 1. Vertical Y means make 1 from nothing. That's why the book title is 021. So as I mentioned earlier, 19 companies out of 20, the largest market capitalization throughout the world is vertical Y instead of horizontal X. But here in Korea, I selected 10 companies. 9 out of 10 companies are horizontal X here in Korea. Samsung, Hyundai, Daewoo, and many others are still here in horizontal X. Only one company in Korea is vertical Y. It's a Naver. Naver is N-A-V-E-R. It's like a Google in Korea, in the United States. So that's why the previous government, I suggest our economic paradigm must be changed from X, horizontal X to vertical Y. I named it creative economy. Creative economy. That means make something from nothing. Here in Google, what makes Google realize this miracle is a search engine. Google Suggest, Nowadays, Google Suggest is very prevalent, but 25 years ago, Google Suggest was a just simple idea. And then the software engineer, they realized those ideas into Google Suggestion search engine. Uber, as I mentioned earlier, not own the car. Instead of owning their own car subscription concept, that basic idea was realized as an Uber. Here in Korea, Naver, knowledge in program. Every knowledge is there. So if somebody asks some questions, another expert can answer. And then it's accumulated there in a neighbor. So that's why neighbor is a major platform, in knowledge platform here in Korea. Intel, everybody knows Intel, right? If your notebook is, if you buy it from Samsung or any other companies, there in your notebook, there's an Intel inside. The reason why the major CPU is made by Intel. So Intel, the founder, one of the founders is Moore. He named the Moore's law, right? So very small, but every 18 months, 1.5 years, the capacity and the size must be doubled. He appointed. The last 30 years, every 1.5 years, the size or capacity doubled. And then 2005, the model number Intel 8088. They are going to expand their capacity 8098, but because of the capacity and because of the the memory size, the heating problem was raised. So however hard they tried, it was too much heated, so they failed. The Moore's law was stopped in 2005. At that time, a truck driver's idea in Israel. At that time, Intel has a research center in Israel. The one truck driver in Israel suggests an idea. The transmission box, gearbox, right? If we have no gearbox in car, we have to push the accelerator to speed up the car. But if you accelerate full speed, and then the engine is heated, overheated. So that's why we have a transmission gear, second gear, third gear, fourth gear. The truck driver's idea was a big momentum to expand, to overcome the Moore's law. So that's why the first, core, multi-core, was a dual core, right? It's kind of a two-step gearbox. So 2005, dual cores invented based on a truck driver's idea. And then next year, the triple core was invented. And another years later, quad core. Nowadays, they have their, the gear state is 16. Like that, instead of electrical engineer or computer scientist, truck drivers, very small, but very insightful, very primitive idea was a motivation of the innovation. As I mentioned earlier, last 50 years, Korea industrial economy was very strong. But the industrial economy requires hard power instead of soft power. The efficiency, standardization, effectiveness, and strong, those 4 words were symbol for industrial economy. Our education system is very much focused on these 4 items. But nowadays, in this great big data ocean, we need creative economy based on soft power, not hard power. To this creative economy, we need differences instead of efficiency, and collaborations instead of standardization, and diversification instead of effectiveness, and flexibility instead of strong power. I always say we are living on 2 different planets. The first planet is the Earth that we are standing on. And the other one is cyberspace or digital planet, whatever else. So nowadays, the GDP, wisely, more than 50% of GDP is initiated from this invisible and intangible planet. As far as the value-added economy is concerned, more than 80% our added value was initiated this invisible planet. So that's why we have to raise the creative education instead of legacy education. So the value of digital planet is somewhat different. If we make one product and we are going to import it to other countries, there's a big barrier, right? Big barrier. So we have to overcome this barrier whenever we reach to other country. But as far as the imagination or patent or science and technology is concerned, there's no barrier between different countries. It's very different. I'm very impressed on Shimon Peres' biography, the president of Israel. He said, science and technology, we don't have barriers in these 200 different countries on this planet. Israel is a very small country. So if we make product and then we are going to expand it to other countries, a lot of barriers. But science and technology and patents, invisible right, there's no barriers throughout the world. Another one I want to raise today is TMY. It's my own term, trillion man-year. The United Nations declared in the year 2050, the population in this earth could reach 110 billion people throughout the world. And their expectation of their life is 100 years. So 10 billion people times 100 years makes 1 trillion man-year. I call it TMY. So the year of TMY, we have to very much concerned about life science economy. Life science makes great new economy. Life science includes healthcare, pharmaceuticals, and food. If we combine those three areas, the volume of the economy will be 18 trillion US dollars. 18 trillion US dollars. And also COVID-19 is prevailed throughout the world, and we have to prepare COVID-19 and after. And also environmental issues and the genetic diseases, a lot of new items, new topics could be imagined to our young generations. As I mentioned earlier, the total volume of the 200 countries throughout the world, their GDP, total volume of GDP is $80 trillion. So 200 countries every year, they produce 80 trillion US dollars. So out of that, ICT, information communication technology industry, occupies $4 trillion. So the total volume of the $80 trillion in throughout the world, the United States occupies almost 25%, Japan 6%, South Korea, we occupied $1.53 trillion. It's about almost 2% of our economy. So our Korean economy is the world's 10th economy throughout the world. But our economy in Korea is very much dependent on ICT industry. You know, $4 trillion out of $80 trillion is ICT, worldwide capacity. So Korea occupies 8.5% of the $4 trillion of ICT industry. That makes our trade surplus 95 billion US dollars. 95 US billion. I mean, the total trade surplus in Korea as a whole is 10 billion US dollars. So out of $10 billion, 10 billion, out of 10 out of $100 billion, right? Out of $100 billion of trade surplus as a whole in Korea, 95.5 billion dollars are initiated from ICT industry. Can you imagine? Almost 99% of our trade surplus is initiated from ICT industry. Very fortunately, we occupy 88.5% of $4 trillion market, worldwide market in ICT. That means our economy here in Korea is very, very much dependent on ICT technology. As an ICT engineer, I'm very proud of that. But from Korean economic viewpoint, it's very unstable. So I'd like to raise another issue like this. You can see the $8 trillion market in the green line. It's a healthcare or life science industry. But our occupation is only 0.8%. So that's why we have to emphasize this green box here, life science industry. So based on strong ICT infrastructure, we can challenge it to blue box to the green box. So my point is we have to expand the 0.8% occupation of the $8 trillion to 8%, right? So expand them 10 more times to the, life science economy. Very fortunately, World Economic Forum declared Biological Century 2018 November. They raised 7 reasons why we have to declare Biological Century. You can see here, death will be optional, biotech will be displaced, relationship to disease will be fundamentally changed. The future of medicine belongs to smaller, nimbler organizations. Previously unimaginable wealth will be created. The drugs will be get smarter. Life science will permeate most industries. Like these 7 reasonable reasons, they declared the biological century. So nowadays, here in Korea, I'm going to encourage our young generations to focus on this biological science, life science area. The other topic I'm going to raise here is FSA instead of FTA. Everybody knows FTA, right? Free trade agreement. Between different countries, there's a big barrier. So how can we lower our barriers as low as possible? But nowadays, I'm going to raise another term. That's FSA, Free Startup Agreement. A patent initiated in 8 countries. And based on that patent, business model in big countries and money in C countries, sometimes we can combine together for the speed up of our startup internationally. That makes global open innovations, like international coordinations between A plus B plus C countries, as I mentioned earlier, intellectual patent or business model in A countries, and solutions in B countries, and the money, venture capital in C countries. But still there are huge barriers there. So we have to reduce our barriers between A, B, C countries, like a triangular relationship and the global coordination and realizing global innovation. That could be a great tool for the international coordination in this dynamic 0 to 1 society. as I mentioned, the creative economy I raised in previous government in Korea, we need soft power instead of hard power. So I suggest first mover strategy instead of the fast follower through the creative economy. And also ICT and science makes creative value because our ICT infrastructure is very strong. And then based on that, the platform, we can add some more different science on top of that. So that's why we initiate 18 innovation centers mated with 18 big conglomerates throughout the country, like Samsung, LG, Hyundai. We assign some region, Samsung for the southeastern region, Hyundai, southwestern region, and then they coordinate with regional economy, very small and primitive economy with big conglomerate. And I also declared software-oriented society. Software is very important. The reason why, make imagination into great innovation, we need some power, enabling power. The software is a very crucial enabling power that makes imagination into innovation. So I made plan to mandated software education from K-12. So here in Korea, since 2018, all of the schools, primary, middle school, high school students are mandated software education. And also software-oriented universities. We have 200 universities in Korea. Out of that, 35 universities we named the software-oriented university. Every students, whatever they major, we teach software in some degree. A school, we teach violin. But the B school, we teach violin plus software. The students in A school, after graduate, they teach violin. The students in B school who have learned software, they make some small AI device in violin, and it connected to the computer, cloud computer. And then when I play violin and the AI very strongly watch that, and then, oh, it's a spring in Vivaldi. And then they select the piano. And then whoever play the violin, the piano sound could be combined together. That's why the software is very crucial enabler, making imagination into innovation. And also we have lifelong software education in some regions here in Korea. Lastly, the important topic I'm going to raise is financing. We have two different financings. It's investment financing and leasing. Traditional leasing financing, the basic concept of leasing finance is risk hedging. So no buoyant finance, no buoyant. But investment financing is risk-taking finance. So buoyant finance. So if somebody has some, if somebody is not good at swimming, but they cannot, they can survive. But leasing, no buoyant financing, if he's not a good swimmer, he can be drowned. Like that, the investment financing leasing investment is very crucial for the software-oriented society or soft power society. So my conclusion today is soft power-oriented society could be a goal of the Korean economy. So make 0 to 1. because we don't have natural resources. That's why STEAM and imagination encouragement is very crucial. And invisible and intangible value is more valuable compared to visible or tangible value in this vertical Y society. So that's why we have to educate the students, have capabilities to create their own job. Traditionally, if a baby is born, his job is there in some place, in some designated time. But nowadays, if a newborn baby, if a baby is born here in 21st century, their job is not here. Their job is not exist anymore. That's why we have to educate, we have to teach how can create his or her own job. And also deregulation is very crucial. As you know well, Korean people, whoever, whenever they go to hospital or go to drugstore, every step was recorded, right? The big data, Korean healthcare related big data is by far the best throughout the world. But for the human right reason, we cannot utilize, right? If we utilize that data, we can make big progress as far as the healthcare is related. But still, that regulation is not deregulated. And also, as I mentioned earlier, instead of risk hedging finance, risk-taking finance is very crucial. And also, our economy, traditionally was the industrial economy. Still, we have 9 big companies out of 10 is still focused on making product from natural resources, which is not here in Korea. We have to import those natural resources by ship. It takes sometimes 2 months or 1 month. So instead of that, we have startup-driven economy. So based on this concept, we are going to change our society as a whole, software or soft power oriented or soft power driven society. That's why all of the audience in this session throughout the world are very much focused on your enthusiasm to the science and technology and STEAM, mathematics and education, something like that. Thank you for your kind attentions. And if you have some questions or any comments, please let me know. Thank you very much for your kind attention again.
Thank you, Mr. Yoon, very much. I am moved by what you had to say, and I wonder if there are others that are attending that would have something to ask you. This is a good time for that. Now's just raise your hand, and you will be or unmute yourself and say what's on your mind.
I'd like to ask a question.
Please.
So thank you, Mr. Yoon. I appreciate everything you were saying about, am I too loud? Test my microphone here. I appreciate everything you were saying about imagination. You were preaching to the choir, as we like to say in America. I brought my flag here. And I appreciated what you were saying about violin playing. My wife and I raised our sons playing Suzuki, violin and cello. And in America, that's not very common to do the Suzuki method, but you start the child when they're 3 years old, 4 years old on the violin or the cello. And it's a significant cultural thing. And I think any country that encourages string playing especially something very special happens to children, not just preparing them for software design or coding, but I think it makes them more sensitive to beauty and to cultural and to expression. What are your feelings about music in general and the arts and making kids more sensitive and expressive?
Mhm. Oh, that's great topic. As I mentioned earlier, I initiated software curriculum to the primary, middle, and high school students, K-12 students. But I'm very surprised that in Israel, Israel also, the software is mandated to the students, but their idea is somewhat different. You know, why we have to teach a software program to the young students? Make imagination make imagination into make imagination make it into the innovation, right? So the reason why we have to teach software or related technology is make imagination into innovation. So imagination is a resource and innovation is a product, right? So the more important topic is make resources, so-called imagination. So not only prepare a special program, special subject in K-12 students, all of the other subjects like art and history and culture, all of those other subjects are supposed to encourage, supposed to encourage more, make more imagination. That's very impressive to me. So I think, but we are here in Korea, we only added just one subject, is kind of software related, subject. But my point is we have to encourage the other subjects are also encouraged to encourage more imagination instead of regular subject. So, I mean, the lesson I learned from Israel is very impressive to me, and we have to modify our all of the other subjects are supposed to be modified into more encouraging imagination. Thank you.
Matthias, would you like to say what it is you typed into the chat? Those are very astute, although I think I may misinterpret something. So would you repeat them out loud?
Yes, I can try. Can you hear me?
Yes.
It's early morning here and I'm drinking coffee, so I'm sorry if I'm not being very clear. But I was thinking what you said about the first mover strategy and the fast follower strategy. And I was thinking that we need both of them instead of one of them. But of course, your idea is better that if we were a first mover strategy and use that, because we need both imagination and collaboration. I see the fast following strategy is also where we borrow ideas and make them better, and we can use them also. But I really enjoyed your talk and it was very nice. And what ideas came from me from your talk is that we need the steam to put the ideas and the imagination back into the science and make the story of science even better. Because if we sell the good story, if we use imaginations and the idea, the 0 to 1, and then we can getting the ideas better and also changing the way we view the education. But I really enjoyed your talk. And here it's about 6 a.m. and I just woke up, so sorry if I misinterpret you. So yeah.
I think you said it said it well. I for one would like to ask you, John, how do you envision the speed at which we can convert education from an industrial economy sort of model into a creative economy model? Do you see hindrance, barriers to that change? And do you have suggestions for overcoming them?
Actually, our previous government started 2013, right? So 8 years ago. So I was appointed Vice Minister of Science and Technology in 2013, right? So the first year of the previous government, I suggested software education here in Korea. But the Ministry of Education in Korea, they said, no. The reason why? The parents have to pay some money for private academy of the software program. You know, in Korea, a lot of private academy there in Korea. So if we add the software program, you know, the parents have to pay more money. So that's why that's one of the main reasons why the Ministry of Education they resisted. And another problem they raised is if we add a software program and then the other subjects are supposed to be removed, right? So that's why there's a conflict. So the Ministry of Education, they said, we don't want that program anymore, right? So in 2014, 1 year later, President Obama at that time declared 50 states in the United States, the software program is mandated. So that's why our government in Korea, Ministry of Education, was shocked, right? And then they restarted the project again.
Suddenly found
That means, you know, the top-down method is not viable here in Korea. So nowadays I suggest to parents of the students. So wherever some parents committee was established and invite me, I go to there. Wherever it is, it's far certain or some island, I go there. The reason why top-down is not viable here in Korean society. So we have to make a bottom-up movement.
Yes. Yes.
Mhm.
I agree 100%. Are there other questions from the attendees for Mr. Yoon?
I have a question. This is Steve Jacobs. Do you, I'm all for more programming and innovative studies in classrooms. Do you think there would be ever a point where there'd be too much, I won't say too much innovation, but too much software? I have a bunch of kids that are geniuses with software, but they can't use scissors or a hammer. You know, does that make sense? I don't, how do I say that, Chris?
You're interested in knowing, I think, how people who are really good with the software can also come back and do the basic rudimentary, so use their hands to create as well. Yes.
Yes. Yeah. I don't know what. Yeah. Something along that lines. Is there a balance point? I don't know how much software curriculum. I'm all for supporting that. I'm just wondering if there's a saturation point with that, as well as too much of something else as well. It's, I don't know.
As I mentioned earlier, software is an enabler.
Yes.
That makes imagination into innovation. So that's why the imagination is much more important and crucial. So
Absolutely.
so the literacy, art, and history, that is also very good, resource of innovation. Resource of imagination. The problem, I think, is, as I mentioned earlier, I have very strong relationships with Israeli leaders, including president and prime ministers and president of universities. And there, I found that, if we have a gun and a bullet, however good gun and bullet you have, if we don't trigger, it don't work. Right? It's stained year by year. It's stained, useless. The problem is triggering power. So usually, the education in Israel is encouraging young generations make trigger. But most of the educations, including Korea, the young generation, they're very lingering or hesitating in triggering the gun. So my point is, and then how can make our young generation trigger with no hesitation? That could be a very important topic, not only to the education, but also the culture, or as I mentioned, the financing system. If we don't have, investment financing, nobody can challenge it to trigger like that. So for the speed of a car, we need very strong engine. That's not enough. We need very light car. That's not enough. The tire pressure was very high, must be very high, right? If 1 out of 3 is failed, the car is not working. That means those 3 items must be harmonized. If 2 are 1 and the other one is 0, and then if we multiply those 3 items, it makes 0. Like that, I think hard power-oriented society, like horizontal X to vertical Y, everything must be changed. Everything changed, but one is not changing. It's the speed of car is 0. I'd call it paradigm shift. So at this moment in Korea, new president election is expected 7 months later. So the leadership is very hot issue here in Korea. So my point in this dynamic vertical Y economy, we need very special leadership, which means, make one from nothing, 0. That requires, paradigm shift, including education, financing, deregulation, something like that.
Yes.
Thank you.
Thank you very much. John, could you stop the share of your PowerPoint?
Okay.
And it's time, I think we will move on to Mike. But thank you very much. Appreciate your work and your words. I'd like to shift now from thinking about creativity and imagination and large, very systemic changes to an example of someone who narrowly focused his creative powers and turned nothing into something. He represents a conversion from 0 to 1, and would love to hear from him. Mike Achera is the president, CEO, and inventor of LuxBlocks. I think I've got all the right titles. He'll tell you more about his background and how he got to where he is and how he made what he's made. Mike, please speak with us.
Thanks, Chris. Well, it's certainly good to be amongst friends. I've known Chris here and Christoph Benavesi and Matthias. And I had the pleasure of hearing about from Steve Jacobs. And I had the great pleasure of hearing at the last conference. Oh, and thank you to, of course, Hogel Park for this beautiful venue. This is, this is an evolutionary, one of those evolutionary processes, the 10 processes of evolution where societies form amongst organisms for more adaptation and survival. And I think the whole bridges idea that came out of Jacob Praff from the last seminar, I was hugely influenced by Jacob Praff in his book in the early 90s, the Connections book. So it was a great pleasure to hear from Jay. So thank you all again for allowing me to be here. It's a great honor. And I just want to say that I wasn't a good student. Frank Lloyd Wright said that everything I remember at school is something I made. I could honestly say that most of the things I remember at school are things I broke. I was a mischievous, violent, distracted student. I hated school. I thought it was jail until probably college, halfway through college. I just felt like I was in a penal colony, and I really resented my time away from foraging through creeks and looking for tadpoles and, daydreaming in the woods. I was a nature child. I like to be outside, and I did not like to be in school. But I do remember distinctly my first great teacher was in second grade, Mrs. Libano. And she was a great teacher because like Mr. Yoon was saying about economies, she created an economy in our classroom. She had currency and she had rewards, and we earned her money. And every Friday she'd have a store and we'd buy in her store. It was an amazing classroom. I had so much respect for her. She was the first teacher I absolutely loved. And I tell you the story because she was a STEAM teacher before there was STEAM. She built, during the year, my second grade year, she built a magnificent terrarium in the middle of the classroom out of plexiglass. And she had in it a little pool, that you could see the side of it, the profile of the pool inside the terrarium with all the layers of soil. You could see the pool, and there'd be hermit crabs and tadpoles and chameleons. And my desk was right next to this beautiful terrarium. And one day I got into a fight with my best friend, Patrick O'Looney. And I used his head to break the terrarium accidentally, and it had a big crack in it. And I got in a lot of trouble, and I had to sit right next to that terrarium the rest of the year. And every time I drew a picture with the terrarium, because I was always drawing pictures, there would always be that crack in every drawing, and that crack became kind of like it affected my consciousness, because I felt so guilty about breaking Mrs. Libano's terrarium that it affected me my whole life. I still remember, of all the grades I went to school, that's a very crystal memory. And my life is a string of obsessions. Okay. And I grew up in a carpenter's family, a construction family. My dad was a builder. And so I grew up on a construction site. My whole childhood, I go every weekend with my dad to different construction sites, and I'd see how buildings were put together. It was an Italian-American family living in Chicago. And when I decided to go to college, I said, well, I want to be, and like Mr. Yoon was talking about, I was a child of Apollo too. So I wanted to go to space. I wanted to be an astronaut. I wanted to build rocket ships and airplanes. So I went and studied aerospace engineering for 2 years, and I failed miserably. I was just not a good student, and I proved it because I did not do well in engineering, but I was still obsessed with structure. And it only got worse, my obsession. So I ended up being an art major and graduating from college. And the first thing I did when I graduated from college was I decided to move to the woods in Maine and spend some time in a hut. And really, it was my last chance to kind of figure things out from my childhood about these obsessions. I wanted to work some things out. And so I began to draw incessantly. I was studying to be an artist. So I was drawing, and I was doing dissections of animals and plants. And I started reading my Buckminster Fuller, and I was obsessed with geodesic domes and with what is structure, and kind of creating thought experiments. So thought experiments like what Leonardo did, or more precisely what maybe Einstein did, where you just imagine something. It could be silly, like Einstein, for instance, imagined being on a train that was going very, very fast. And the faster it went, he imagined if you looked forward outside the window, things would get bluer. But if you look back, things would get redder. And that was his way of understanding how light waves would get compressed as you're moving closer to the speed of light. That was a thought experiment. My thought experiment had to do with a book I had read by Peter John Pierce. It was a book about, it was called, oh boy, what was the name of that book? Nature is a Strategy of Design or something like that. Peter John, it was a very popular Black book back in the 1990s. And Design is a Strategy of Nature, something like that. But Peter John Pierce wrote this book. I was very inspired by it, but the problem I gave myself, the little exercise I gave myself was, he said he had a principle called the min-max principle, minimum inventory, maximum diversity. He said that what you want to do is you want to optimize, and nature is the greatest optimizer of all. 92 chemically regenerative elements build everything in front of us, right? He was trying to find a modulator, a very small, it was important to be small, a very small family of modules that can build the maximum diversity of outcomes, okay? Well, I became obsessed with that problem. And I said, well, what if there was one? What if there was like one thing, this little atomic, this little structural atom, and that structural atom could build everything? And, you know, not that there's any evidence that such a thing exists, but it was a thought experiment. So I started really putting things together. And I discovered, you know, it's one of those things where if you really want to find something, things start to fall in your way. It's like providence or something. But a friend of mine asked me to help him clean out his apartment. He was a kind of disreputable, you know, ladies' man artist, and he always was wintering in Mexico, and this was his main. So he had an apartment full of all these things he'd bring back from Mexico. And some of the things he had were these cuttings from palm trees that were shaped like a Y. And I said, those are really cool. I'd love to draw those. If, yeah, I draw those all the time. You could have them. So I brought all these Ys back to the forest where I lived in this little cupcake shaped hut. And I was playing with them, and I started building domes out of these Y shapes. And I was like, wow, I'm repurposing something that was completely different. It was a palm frond. It was the base of a leaf, but I was repurposing them into geodesic domes, and they were forming into perfect little domes. And I was like, wow, that's interesting. So I started thinking about this Y shape. Well, anyways, long story short, I developed a theory of what structure is and how the universe is working. And it basically goes like this, that structure is everything. Everything in our life is structural. You know, smoke, fluids, buildings, leaves, babies, it's all reducible to some kind of a structure. And so when I finally came down to inventing Lux blocks, I said, well, what we got to do is we got to find one thing. And what the thing's got to do is it's got to form into structures, and it's got to make structure from non-structure. So here's an example. Here are Lux block squares, and they make a membrane, okay? And the membrane is very flimsy. It's not structural at all. And what I use as a definition of structure is a structure is something with a tendency to hold its shape. Okay, that's how I define structure. It's a tendency of something to hold its shape. That thing has structure. Okay, so this thing doesn't have much structure at all. But the minute I folded it, I have instant bridge. Okay, well, that was a significant thing for me because I thought, well, that's one of the things that passes my litmus test of structure. Another thing was that it had to be modular. Okay, it had to be self-similar. These are qualities I wanted it to have. So I wanted one thing to do lots of things. Well, the nice thing about squares is the squares make prisms. And the nice thing about prisms is prisms adopt different polygon faces. Okay, so the square makes a polygon that's not a square, and the polygon has active edges. Okay, so essentially that's another place to connect something. So I have a triangle. Okay, so I can make a triangle, I can make a pentagon, I can make a hexagon. So I was making all these I was making platonic solids, Archimedean solids, and that was like, okay, our litmus test is looking pretty good. So the question, the thesis of today's presentation is, people often ask me this one question, you know, how did you invent Lux and why did you invent Lux? Okay, I invented Lux, the why I already addressed. The why is because I was obsessed with how the universe is put together. For me personally, I wanted to know, okay? But then it became an obsession about, I want to know because I'm a human being and obsessed with this, and I can't be alone in this obsession. Of course, I've discovered later on with Bridges that there's lots of people obsessed with how the universe is put together, lots. So I was nice to find a family and a tribe finally. But the other thing was how I did it. And I did it by just lots of failure and lots of thought experiments, lots of just trying out different crazy ideas. So I came up with this idea of this square with these connectors. And what I found right away was that it was teaching me things. So I realized I had found a kind of a tool that helped me further discover things. Okay. So the thing about an active edge on a polygon is, sure, you can make static things. Like I have these 4 prisms here. Okay. These triangular prisms, and they make inside a tetrahedron. Okay. They're defined. It's technically, this is like an extrusion of a tetrahedron because I'm defining the sides by these prisms, but it's super stable. But what happens if I make a happens if I have 2 triangular prisms, which are totally structured? Triangles just make structure. They don't move. There's no movement. But now I had introduced these square prisms, and squares have this tendency of not being structural. They tend to want to turn into rhombuses. They want to kind of do this. So what I found out was I could have some stability and some instability, and I create a completely new kind of creature, a creature that's kind of in between structure and non-structure. Okay. And if you were here and feeling it like I am right now, if you were a blind person and just feeling this, it feels like there's like a magnetic field between these 2 prisms. It's floating on a cushion of structure, and the cushion is seamless. It's like the most beautiful thing. It's like a gimbaling system it's like a force field. And I was really intrigued by that. I was like, this is just crazy stuff, right? So, and I found out there was all kinds of things like that. So if I had all prisms that were squares in this like XYZ cubic right here, this thing just goes in all different kinds of directions. It's just a beautiful kind of gimbally thing. Okay. A dynamic structure. And so now I was really getting interested because I was obsessed with nature, and nature is not just about crystals and rigidity and solid things, but it's also about babies and tadpoles and little, things that are squishy, right? And have other properties besides rigidity. And this is like squish, but these are solid blocks, but they're mechanically reducing squish, which is, I remember when I first uttered that, like, this is mechanical reduction of squish. That's what's going on here. It's one of the things we do. We tend to have words. I'm against worksheets. I think worksheets should be illegal. I don't think that when you teach science, you should have worksheets. I think worksheets diminish everything, and they reduce nature to little knowables. And I think the most beautiful thing about discovery is admitting, like the teacher admitting that there is mystery and unknowables. I think that's what inspires everybody. Not that the teacher knows more than the student, but the teacher is also a student with the student, right? So we assume that squish is just something does. A pillow is squishy, right? We don't think the pillow is really like mechanically reducible to something, but actually the pillow is mechanically reducible to some kind of mechanical phenomenon. But it's so macro, there's so much going on that we can't tune into it. So that's what I was interested in. I was interested in tuning into things like squish, for instance, right? And this thing, I kept exploring this stuff. And this is for instance, this is a hexagon with square prisms around it. And it continues to exhibit this kind of quality, right? That I just find so interesting that I wanted to share it with you, because this is something that I love about nature. I love this aspect of nature, right? So, and also what I found out was these things can be put into series, okay? And so you're seeing things in terms of system. Okay, and again, I was a complete fanatic for Buckminster Fuller, and Fuller was a systems thinker, a whole systems thinker, a systems thinker, and it was the idea of seeing whole patterns, whole systems, as opposed to just disciplines by themselves, but seeing the whole pattern of something. And I like the idea that chemistry and biology really are just kind of variations on each other. Okay, like biology is basically applied chemistry. Okay, and then you see that when you see, and if you reduce chemistry down to structure, then you see that everything's kind of an applied structure. And I don't think that's really kind of too much of an imaginative leap. And I think that also frees children, especially the troubled kids like I was, to really wonder, like, what is everything? What is going on? And I think that's part of that whole creativity, is like admitting that we don't know a lot still about what's going on, and giving them a tool of discovery like Lux Blocks enables them to use their hands and put things together, and especially come up with things that the teacher has absolutely no idea what they just made. I love when a kid asks a teacher a question, the teacher has absolutely no idea what the answer is. And that's what we tried to do with LuxBlocks, try to create something that really probes what nature is. It doesn't give solid, concrete answers. It kind of pushes the limits, right? So I wanted to share a few things with you guys. So some of the discoveries that happened with LuxBlocks was motion. So when this happened, we were like, yeah, I don't know what that is. That's just freaking weird, right? And these are called, does anybody know what these are called? I saw these faces out there. Does anybody know the technical term of this? I mean, it's really the motion of like a plie, like a ballerina's plie, right? It's basically that motion of like legs, right, going down, or hands doing this. But there was a Frenchman named Serres, and this is called a Serres linkage. It's a thing. And LuxBlocks wants to make Serres linkages, right? And it loves to make Serres linkages. And basically you have a frozen prism and another frozen prism, right? And then you have the same elements of the prism that are not frozen. They're free, they're little bridges. And they have a transitional phase, right? And that interests me because, you know, if you think about nature and think about evolution, the adaptation really is the adaptation of the same parts, right? And they take the material of those parts, and they might be a rigid part of an arthropod, and then there might be a flexible in-between part of that arthropod, and then another rigid part, and you get digits, and you get things like little crabs, for instance, right, with little legs that move, right? So the idea that a kid can make a rigid part, and a non-rigid part, and then make a new creature is interesting. And then you can make it bigger and wider and change the frequency. But then a kid named Gerard Remis, who's now a sophomore at Benedictine College, when he was like 12 years old, he said, you know what? I've discovered you could actually you could make it go out this way too. So he opened it up and made it so these cells actually expand laterally or horizontally, right? And it still works. So now you have these pocketed cells all in this arrangement, right? And whoever would have guessed that would happen? It's like an emergent order. It's like from this thing comes all these other things, right? And that made me think, well, I think we're onto something here, because these emergent orders are like Mr. Yoon was talking about. When you have complex economies, new things happen, like Uber. Who would have thought that would have happened, right? Who predicted that? But in nature, you see this all the time, where new kinds of species, new kinds of adaptations occur out of who knows where. So this is, to me, this is really interesting emergent order. It's wonderful to play with. No teacher could explain it, it seems like, because it's weird, right? But it seems to be, again, like a mechanical reduction of a squish. It's cellular, it's self-similarity. A biochemist in Queensland, Australia, Ken Colleen, says it's a closer approximation to the lipids in muscles than rubber bands are for explaining muscle structure and the mechanical tensors inside of biological systems. So that was interesting. Excuse me, microphone bouncing. I muted myself. Okay, so now, and then again, the thing about prisms is, then I'm going to jump over to trigons. But the squares, when we first started the company, we only sold squares, right? Because the squares were just so wonderful, because prisms seem to make everything, including things like Buckminster Fullerene, because the prisms define these active areas that are different polygons. So we were able to make all these different kinds of creatures, and they were a blast. But then we introduced a new one called the trigon. So trigons are triangles. Trigon is the old Greek word for triangle. So it's trying to be cute. So a trigon is a triangle lux, and you would think, you think about, you cut it in paper, you let kids do all kinds of things with polygons, but when they're in lux and you have these active edges and these strong connections, the kids will squeeze it, right, and put it around themselves, and it'll conform in really organic ways, right? It has a creature quality to it, and I use that word creature because it has a kind of creature quality. Like it feels like it's conforming to your own hand or your own structure, okay? And it is. And it also imitates pretty closely like nanotech. So if we have a hexagon structure going this way and we align it differently this way, they exhibit behaviors where when they coil up into different things, right? This one coils up into a prism that's an anti-prism prism, essentially. It's made with anti-prisms. This one coils up a little bit differently. It could still make the same thing, but it behaves a little bit differently. And you can see the two different kind of nanotubes it makes. These are two different species of nanotubes, okay? You can see the ply in them are a little bit different. The way the hexagons go up are a little bit different, these two nanotubes. And these are things that now we're talking about reduction into the real sciences, the real things that are going on in research. Nanotubes are a real thing, and they're being studied actively right now because it's affecting metamaterials and biomimicry and new kinds of technologies that are very, very small. And so the idea you can put these in kindergartners' hands and they could be making things that are being studied in university, just who's to complain about that, right? So again, it'll make a buckyball. But what interests me is that when you make a tetrahedron out of these things and you leave one face off, it'll squish, and it'll adopt these new kinds of forms. So you're dealing with the A in STEAM too, where the kids like pondering, eyes or dinosaur head, with the tetrahedron, gets to an octahedron, which is basically 4 triangles instead of 3, squishes it, dimples it, manipulates it. He's using or she's using their brain to create all these crazy forms that are just off the scale on complexity and pattern, right? So they're seeing pattern, they're recognizing pattern, they're maybe creating algorithms in their head where they can say, if I keep doing that, I could maybe make something else, right? So they're discerning a kind of regularity or a new kind of pattern. So as an artist, I find that interesting because it's not just about, I have a vision of what I want to make. What's interesting is you start to push the clay, push the pencil, and sometimes what happens is the art kind of comes, right? And you're oftentimes just dictating things as they're coming to you, and you're making connections, but you're not the sole author in a sense, because the material is kind of dictating to you what's going to happen. If you squeeze a pentagon, right, it'll form like a Y shape, that one that I used to be obsessed with, the little Y there, right? But it'll form a lot of shapes that are just interesting to a kid. He might see spaceship and cockpit of a jet, but they might see hand or prosthetic arm, okay? So this was the reason why I made Lux Blocks. I wanted kids to be able to explore 3-dimensional space in a very dynamic way. I wanted a moving block that would get kids like I was interested in making things that stimulated them, but at the same time had relevance to the world in the sense that it related to science, it related to engineering, it related to biology, it relates to everything, because everything is essentially structure. So yeah, that's kind of what I got. I mean, I made a lot of models. I was telling Chris I had gotten dehydrated. My hands started to seize up on me, but I made some models for you guys to show. Here's you probably recognize this one. This is the season of the virus, right? So this is a bacteriophage. And again, this is made with almost all trigons. And here's your little nanotube here, like the helix going up into a icosahedral structure, cage structure here, right? What Lux usually does is it makes all its structures are usually cages, okay? They're usually hollow, and all the structure is tensile, and it's in the skin of something. So including this rocket right here. So, excuse me. So it also moves. So a kid could make something like a virus, and they could think about like why it's moving and what does motion have to do with anything. One of the games we encourage teachers to play is called Creature Feature, where basically the kids, we make evolution a competitive sport, which it is. And the kids team up in the classroom and they all make creatures. Usually they pick a period, like maybe an early period in Earth's history, which is just like a shallow sea. and they have to make creatures in this like lagoon, and the creatures have to compete with each other. And when the kids get done, the kids will orally defend why they decided to put these different designs in their creature. Like my creature grabs things, right? Or it scoots around because it has a little bladder and pushes things. And then the kids will vote on what creature would survive ultimately in this environment and do the best. So that's one aspect we try to bring biology into the equation. And lastly, move some of the stuff out of the way. We have 7 parts in our inventory. So we try to keep it a very simple system. We're all about min-max, trying to maximize. So the wheels in Lux Blocks are also gears and pulleys. We want to have the kids have success. So the wheels are connected with rubber bands. So that way they could have different lengths with their little wheels and they could still have success. This one shows a Roman sawmill. The Romans were considered the first to have probably a hydro-powered sawmill. So this shows a circular motion making a back and forth motion. This one here, I made at the Illinois State Fair. So this was going to be an oil well, but then I felt like an oil well was kind of boring. So I turned it into something else. Let's see if this works. So this was going to be an oil well, but I said, I made a hammer. And all the kids loved it. They wanted to put their hand under there and get crushed. So, and then I had, let's see, I have machines. Okay, so I guess my presentation was shorter than Mr. Yoon's, but that's what I've got. So I'd love to answer any questions anybody has, except for Matthias. He's too difficult. So anybody else have a question? Matthias can go last. And if you got a question for me, I'd love to take it. I can't hear Chris. Chris, you're talking, you're muted.
Sorry about that. Steve's been making comments to me, and I think he meant to put them in the everyone. But that's is it all right that I share what you?
Yeah, I couldn't see what I'd love to hear what Steve had to say. I couldn't see what he was saying when I was talking.
Hang on, I gotta get my oxygen turned up. Oh my God.
Can we slow Mike down just a little bit once in a while?
Now what, are you allowed out in public? I mean, do you have a bracelet on or something? Or are you in?
Yeah,
man, goodness sakes alive.
Was I going too fast for you guys? Sorry.
You hit the accelerator, that's for sure.
Oh my goodness, Lord save us. You must be the healthiest man I've ever met. It just came out of you like a Gatling gun.
I run from the position of always feeling kind of like an idiot. So I'm like, oh my God, be smarter.
You're dangerous. You're a dangerous man.
Well, I got all these things, they help me.
What did I write? I forgot. Mike, Chris.
You were saying a few things about the speed at which he's delivering his materials for us here. Pretty much what you just said. So
okay, good. No, I was very impressed. It was like a whole. It's like watching a fireworks show all at one time. Like everything is going off in the sky at the same time.
I apologize.
No, it's wonderful.
My first keynote, and I wanted to get it all in. Then I was like, oh shit, I got it all in too fast.
No, it's just wonderful. It's like I can only eat ice cream so fast. You know what I mean? It's like,
I could reiterate any aspect that I went too fast over. I'd love to tell you about. Basically, I was trying to. It was like a show and tell. Essentially, I was trying to show you all the things that get me going.
Oh,
So I'd like to ask a question, if I could, Mike, about the switch, the shift from the square block to the trigon.
Mm-hmm.
What was some of the creative, innovative thought that was going on? Because I know there's a significant gap in time between those two developments, aren't there? Isn't there? It seems
truthfully, okay. The way Okay, the way it really developed was the real story. So we had a 3D printer. I was a mentor at a FIRST competition, which a robotics competition. And my son's friend, Daniel Volin, German immigrant, prototypical Uber German, wunderkind. And he learned AutoCAD to get points for his team. Because if somebody in your team learns AutoCAD and can put the machine design in AutoCAD, they get extra points. So he learned AutoCAD to a significant way. And I was a portrait painter. And I told my wife, that idea I've had for a while, I think that if I make drawings, Daniel could put them in AutoCAD and we could print these things and see if they really work. So we started doing that. We jobbed it out to a company to prototype for us. And that was horrible because it would take forever to get the part back. You'd put it together in 2 seconds, you knew it didn't work. And then you had to do it all over again. We finally bought a printer. This is 2013. So we bought a MakerBot 2X and we started rapid iterations, like sometimes 2 a day, where I'd walk over to his house, show him what he did, show the design he had made, like in AutoCAD. I'd printed it. I said, change it. And we'd do 2 or 3 iterations in a day. And then once we started, we probably did hundreds of iterations. And we made thousands of blocks on this printer. And in the process, we had made squares and triangles and hexagons and rectangles and all the shapes. And in the patent, there's dozens of shapes, all different kinds of things, right? It's an exhaustive patent. But then it's the economy of making a mold. A mold costs like a secondhand SUV to a new SUV. That's what a mold costs, a steel mold to injection mold your parts. So we decided, since the squares have this great ability to make prisms, so let's just launch the square. Let's just do that first and see how it goes. And it wasn't until, and it did fine. We were doing fine. But then Target got interested in us, and Target said, we'd like to put you in our store, but we'd like you to make vehicles. We want vehicles. So I was like, oh, goody gumdrops, because now I finally can make my wheels that we had designed, and I can get my trigons put in there too. So it justified 3 more molds, the Target thing. So it was always in the works. We knew how they worked, right? It wasn't like, oh, now I discovered the triangle. Ooh, no, it was like, we knew what the triangles can do, but we just knew the squares are a cheat, because I think nature has 2 aspects. It's prismatic and it's anti-prismatic. Okay. The anti-prisms are, the anti-prisms are like tetrahedrons, for instance, or helixes, or anti-prismatic. Prisms are bounded by rectangles or squares with different polygons on the top and the bottom, and anti-prisms are bounded around the sides by triangles, right? But you could do a cheat with these, because these will make virtual anti-prisms. They'll make triangles and hexagons, so you can get away with a lot of squares. It's crazy. So that was neat. That was a neat cheat. So that's why we had squares first. Did that answer your question?
Yeah, that got pretty close anyway.
But I had no idea though what tons of these would do. And once we got boxes of these, it was like Christmas. It was mental candy. It was great. So yeah, it's one thing to print them off and have like a couple dozen triangles, but they have thousands of triangles. Oh my God, it was nuts.
So do you realize the vocabulary? Now I'm thinking of a 5-year-old kid or whatever age these are designed for. The vocabulary you used tonight about anti-prisms and tubular, just remarkable math terms that I'd forgotten since geometry class. Extensive use of vocabulary.
Dude, we got kindergartners telling their mom that they made a gyro bicupola in class today.
Yeah, that was
freaking gyro bicupola, man, which is the Johnson solid. And most academics don't think about Johnson solids, but these little kids are like, I just made a bicupola, but Jerry made a gyro bicupola, because it was off by 1. So I love that kind of stuff.
Do you think they understand that? I mean, they get the syntax of those.
Well, it's not. I don't think it's important. In the beginning, it's not important. The important thing is they are making toroids. They're making cupolas. Matthias is a cupola master over there. He's like the master blaster of all cupolas. But cupolas are in architecture. They're so like you're saying, they're learning the shape language kinesthetically. They're building it. And as you would know, Steve, that's like really important, that they're making those kind of physical hand-on connections with things. It's not a horrible worksheet that should be legalized. I am serious. I think worksheets are like bad.
I never would have gathered that from your.
It's not an unpopular thing that you're preaching to the choir in this room.
I know.
Are there other questions for Mike? Please just unmute yourself. And
I'm really proud to meet somebody that can make a living. I mean, make a living doing that. And that's just like, I don't know what to say. In fact, I'm talking to Tarzan or somebody. How do you live out in the jungle? And, you know, look what he's doing. I say that safely behind my desk, you know.
It's been really, I'll tell you, it's really, we violated the first law of business. In business, you're supposed to invent something that solves a problem everybody has. We made something that solves a problem that no one knows even exists. Okay. So it was like, I went to an entrepreneurship thing and I was like, first off, we did the worst thing possible. We solved a problem nobody gives a shit about, but that's the hump. That's the thing we had a hoe was like. So what we did was when we went to Target, this is part of the history of our company. We got into Target, not a year after we got into Target, it was like 6 months. We were at the toy fair in New York City. And there was a rumor going around the toy fair and it was making everyone just turn white. And that was that Toys R Us didn't pay a bill. And that kind of news at a toy fair ruins the party. And not a month later, Toys R Us declared bankruptcy. And that, luckily, we had already started a pivot because we hated the toy industry. We did not like it at all. We don't like the nature of the toy industry. We're educators. That's our heart. So we had already made a pivot and started selling hard to education supply houses with another kind of product in big Sterilite bins, you know, selling to schools. And we pivoted right before that catastrophe happened. So why am I telling you this? Oh, because yeah, that kept us alive was having to make that sell to having a desk like this, a booth in an education fair and talking to teachers and just the wow factor. What first happens is they buy us because they say, well, that'll engage my kids. My kids will like that. I don't know what the hell it means as a teacher. I don't get it, but I know the kids are going to like it and they're kind of sick of the Legos and Connects. So we got in just on the wow factor, but now people are coming back to saying, do you have curriculum about biology? Yeah, I do actually. So it's getting more interesting now that people are saying, yeah, we're going to use this. So it takes a while, but it's happening.
Where can people find Lux blocks? I mean, those in this meeting who don't have a local Target or don't even know what a Target is.
Well, in Europe, Christoph Fenavesi knows people. So you should talk to Christoph about that. And I have a connection in Japan, a distributor in Japan right now. We just got him about 6 months ago, and he's an excellent person. And he's looking to sell Lux blocks in Japan. Maybe Hogel Park will start selling us in Korea. That'd be cool. And where else? And in the United States, it's mostly online. We're sold on Amazon and our website, and we're sold through things like Kaplan Education and NASCO and companies like that.
Okay. All right.
I was at the state fair in the first time they had a STEM booth, and it was a STEM pavilion. And so I went around and I went to the University of Illinois Aerospace booth. And I was talking to them. I made a little rocket for them and everything, one just like this in Illini colors. And they were excited because they were about to build a satellite for Fermilab. And the satellite, its job was to do one thing, look at the center of the galaxy and measure a very narrow X-ray band. Okay, it was like a tiny X-ray band. And if the center of the galaxy was emitting a signal in that band, people were going to win Nobel Prizes. But the other X-rays in space were too diffuse or something. They couldn't tune into that. So this U of I team was building that satellite for these Fermi scientists. And I said to them, I said, you know, if you ever need a block guy to help you out and build something for you, and I've done 12-foot SR-71s. I could do aerospace. You know, I'm a failed aerospace engineer myself. And he said, could you build a mock-up of our satellite? I'm like, can I build a mock-up of your satellite? So that was fun. I love making relationships with universities at that level because it's really interesting how, even though they're making rockets and satellites, they still love blocks. They still love construction. They still love it. It's really cool.
I have a question too,
Mhm.
Mike.
Great.
So I see that I saw it many times that what kind of discoveries children have with looks, and I'm sure that you have many more experiences. But what was your greatest discovery with looks? What you never sort of expected when you started to use your tool? What did you find yourself?
Well, there's different levels of, there's different levels of belief in your own invention, right? Like you just think like, at first I used to think like, oh, maybe I'm really putting a square peg in a round hole, and I'm overemphasizing, making too strong of claims about what this thing could do. I was having doubts for a while. I was like, I think it's cool, but maybe it doesn't do biology. Maybe it doesn't do chemistry. And then chemists would come to me and say, I bought your blocks and look what I did. Henry Siegerman made an announcement. Everyone knows Henry Siegerman. He's a kind of a monster. And he made a proclamation in 2016. He said, I discovered what the secret of Lux blocks are. It does hyperbolic shapes. It makes, so he showed how it does hyperbolics. And then I had a woman who's got DOD clearance out the wazoo. She's a brilliant coder and mathematician. And the things her children are doing now with Lux blocks, I've been posting some of the things her kids have been doing. It's off the chart ridiculous. Like they're doing things I never dreamt the blocks can do. So who surprises me the most with the blocks are not me, but the kids on the spectrum are killing it, especially the ones like the savant types, that are kind of odd, but really, really creative in different kind of ways. So we've done really, really well with kids on the autism spectrum. And that was never anticipated. That just happened. So I'm more proud of that things like that are happening. Okay, another story is a quadriplegic doctor who went to high school with my father-in-law. He became a very famous doctor. He was famous for being able to read the X-rays, right? And the different kind of scans, those MRIs and stuff. He ended up being a professor of this, but he became a quadriplegic in high school in a wrestling accident. He is obsessed with Lux blocks, even though he has very little use of his hands. He has his manservant kind of build them for him, but he's obsessed with Lux blocks. And he asked to have a special class made in our factory when he came to visit Galesburg. And he and his friends came, and we made the special kind of classroom in the middle of the factory. And he wanted to do a whole lecture series on Lux blocks to his friends about how you can make flowers with Lux blocks. And things like that are just so special and just freak me out. So yeah, those are just two random stories.
Thank you.
Mm-hmm. On the horizon, we're coming out with electronics in 2022. We've got, we'll have motors, and our philosophy about electronics is, Steve Jacobs might resonate with this when Mr. Yoon was talking about software. We think, we're kind of Yankee tinkerers, and we think that electricity is interesting enough at first. Let the kids have a power source, some wires, a motor, maybe a little rheostat, little switch, and let them have fun seeing how work is translated from the battery to the motor, and see how there's so much that can be done with that. I tell people all the time, kids in the 19th century had an advantage over the kids now in this sense. A kid would go and he'd put coal in the boiler in the morning for the workshop, right? And it would heat up the boiler, and that boiler would turn this piston, right? Push a piston, make a wheel go around, and then it would engage the belts. And the craftsman would come in and they'd turn the clutch, and the belt would come down and turn the lathe or the sewing machine or whatever it was. And that kid would see from that coal the work that went around that room, right? But the kids today, electricity is like magic. Tablets are like magic. Even the coding we're teaching kids, a lot of that is object-oriented fake coding. They're not really coding anything. A coder has made them feel like they're pretending to code, and they're not. So I'm kind of a little jaded about when people are saying their kids are learning coding, but they haven't learned like the basics of electricity, and they don't know like what a DC current is and AC current is. I think that there is a hierarchy of learning, and it's actually really fun to let kids just play with spark a wire and play with electricity and with the basics of electricity before they get on to like just doing more stuff on tablets. I think that that's just a shame. They should be working with their hands and playing with this stuff. So that's what we're doing. We're doing that. We'll do tablets and Arduinos and coding later on.
Well, thank you, Mike. I for one am really appreciative of your enthusiasm and your inventive and innovative approach to getting discovery in the hands of children, helping them investigate the core of how the universe works and gets put together and stays held together most of the time. And that's just a great thing.
Thanks for the opportunity. I appreciate it, man.
Yeah. At this time, we're done a little bit early unless there's some other questions. Mr. Park, did you have anything you wanted to say before we signed off for the evening? You're still on mute.
I think we can just move on to the next phase, since Mr.
Okay.
Park doesn't have anything much to say this time.
Okay. Okay. So, well, the next phase is really to say thanks to everyone for coming, and we'll be back again in about a month.
Yeah.
Yes.
Sweet. That's good news.
Yeah, that is very good news. And we'll have a couple more presenters. So keep watching your email, and you'll hear more about when and who as time goes forward. Thank you all for a very great evening, and we'll see you in September.
Thank you very much, everyone, for participating. Thank you.
Thank you, Mr. Yoon. Thank you, Mike.
You did a good job, Mike. I don't think we need to get you two guys together. It would be dangerous. Very dangerous.
I'd love to work with you, Steve. That'd be awesome.
Oh, we will. Definitely. Sounds good. See you, Christoph.
I really enjoyed.
Bye. Thank you.
Thank you.
You inspired me. That was very excellent presentation, Mr. Yoon. I want to steal some of your ideas, if you don't mind.
Thank you. I really enjoyed talking with you all. Thank you.
You betcha.
Thank you very much again.
Thank you. Goodbye.
Good night. Have a good day.
Good night, everybody.